All right, Annalise, what's our title today, hon? Perfect. Guys, what shape does it make for a quadratic equation? A U, right? Upside down or right side up, it depends. So here we go. Understanding the features of a quadratic and how to find them. Common phases and concepts. Here we go. So in an application, students, X value or X represents the input. Okay. The X is going to represent your input. Y, Keely, what do you think Y is going to represent? The output. You are correct. Okay. What was the starting height? Okay, so think about this. This is sort of a normal question in a quadratic application. What was the starting height? What do you think that means in plain English? Means what? Yeah, the starting height, students, is when time equals to what? When time equals to what? 0. Time is usually input. Input is X. X is 0. Then Zoe is right. This is going to look for the Y intercept. Okay. When did it reach the maximum height? Ooh, good question. What do you think this is asking us to find?
The vertex.
The vertex. Which part of the vertex? You are correct. When means time or height? Time. Time is input or output? Input. So which part of the vertex? The H value of the vertex or the K value of the vertex? You are correct, okay? So this is definitely the vertex, but just the H value of the vertex. By the way, how do we find the H value of the vertex, students? What's the formula? We have to know this. Yes, Chris, good job. Negative B divided by 2 times A. Beautiful. Okay. What was the maximum height? Guess what this is? What is this if we are asking you to find the maximum height? What do you think? Lonnie, what do you think, hon? Yes, the K value of the vertex. How do we find the K value of the vertex? What do we do? What do we do? Yes, good job. Hold on. Plug H value in. Okay. Now, when did something land? An object, a ball, you know? If we're shooting something up there, something has to land. What does that mean? When did it land? Yeah, because think about this. If something lands, what's happening to the Y value? Where's the Y value? It's on the ground, right? Y is on the ground. It's 0. You are correct. When did it land means Y equals to 0. So this means you're looking for the x-intercept, just like what Brad said. Okay, good job. All right, Chris, can you please help us read the first question?
Use the graph to the right to answer the following questions. Assume seconds and feet are the units.
Good. So students, seconds is your time in unit, and feet is going to be your time of the output. Okay. Jillian, help us read part A, please.
What was the launch height?
Okay. What was the launch height? I know your packet probably is a little more blurry, so I'm going to make this bigger. So Jillian, what was the launch height?
50 feet.
Yeah, 50 feet. Good job. And I like the fact that you said the unit with that. 50 feet is perfect. Jacob G, can you read the next question, please?
What was the maximum height?
All right, I'm going to pinch it in for you to see, Jake. What do you think, bud? Yeah, I agree with you on that one as well. 200 feet. Can you please help us read Tanner part C?
When did it reach its maximum?
Okay, so what do you think, Tanner? Make your best educated guess here on this sort of blurry vision. When? About?
3 seconds.
Yeah, 3 seconds sounds like a good number to me. Okay. Okay. D, Sophia, help us read part D, please. Okay, so now make it bigger. When, Sophia, do you think this object is 100 feet above ground? And we're going to try our best educated guess to guess this one, okay? Actually, I have a ruler. Let me see if I can make this. So, come on, 0 degrees. There you go. About what time? Okay, so the first one is how many seconds you said? Yeah, I would like that value as well. How about the second time? Because it hits 100. Yeah. Okay, we're just going to approximate those. You can do 5.6, right? 5.7. But those are our approximations. So 0.5 second. And you said 5.5, Sophia? Yeah. You are? Yeah. Those are good numbers. E. Brad, can you help us read part E, please?
When did the projectile land?
What do you think? What's your best educated guess on that one?
Like 6.75.
I like that number too. Yep. It's going to land in about 6.75 seconds. So those are the typical questions that we ask you, okay? So about 6.75 seconds. Perfect. All right, Ian, get ready to read question number 2, please.
A baseball is hit falling according to the following equation. H
Of t.
40
H of t.
equals minus 16t to the power plus 96t plus 4. Where is multi? Where's H multi?
No, that's H of t.
H of t is height in feet and t is time in seconds.
Good. So remember, we have to know the unit of measurement. H of t is your height in feet, and time is in seconds. Okay, good reading. Thank you. Val, can you help me read part A, please? Good. So Val, what are we looking for when the question asks us when did the ball reach its maximum height? The what? Is it the K value, students, of your vertex? No? What is it, Sophia? Yeah, when represent input or output? Input, because that's time, okay? So it is the H value of the what, Val? H value of what? No, remember? Go back and read your thing up here. When means what? The H value of what? In your notes, the first few lines of the vertex. And how do we find the H value of the vertex, Val? Good. Okay, so now Val, on our equation, A equals to what? Good. B equals to? Great. C equals to? Beautiful. Let's plug it in, y'all. Okay. So negative B, what? That's going to give us negative 96 divided by 2 times A is negative 16. So Kyle, what is 2 times negative 16? So Kyle was negative 96 divided by negative 32, bud? 3. Do you guys all agree with that? And then what's the unit of measurement for this one, Kyle? Is it feet, students? Is our input feet, Kyle? So Kyle, when represents what? Height or time? Time. And what is your time measure in this problem?
Seconds.
Perfect. Much, much better, bud. So in 3 seconds, it will reach its maximum height. Tyler, help us read B, please.
How high in the air did it get?
So Tyler, how do we find how high?
The K value?
Yeah, how do we find the K value? So look back at the first few lines that we just spell out.
Plug H in.
Yeah, what's H?
3 seconds.
Yes, guys, so find the height by doing when time equals to 3 seconds. So h of 3 equals negative 16 times 3 squared plus 96 times 3 plus 4. All right, Tyler, what's 3 squared?
9.
9 was 9 times negative 16. Get a calculator, buddy. I know. I have so many that you can borrow. Look at that. Guys, go grab a calculator if you don't have one. Positive or negative?
Positive. That's not negative.
All right. Continue, Tyler. 96 times 3.
288.
288. Drop the 4 down. Now punch it all in. Give me an answer. Someone confirm that with me really quickly? Yes. Now, unit of measurement.
Feet.
Beautiful. Good job, bud. So in 3 seconds, it will reach the maximum height of 148 feet. Okay. All right. Let's move on to example 3. Jake S., can you please help us read example 3?
A model for a company's revenue from selling a software package is R equals negative 2.5 P squared plus 500 P, where P is the price in dollars of software. What price will maximize the revenue?
Good job. So Haley, what does P represent in this problem?
P,
Mm-hmm.
the price.
Oh, very good. So guys, if it's price, what unit is that? Price is what unit? Dollars, yeah, for sure, dollars, okay? So, Sam's not here either. I don't think I marked Sam out. Okay. Ethan, what is R? What does it represent? Revenue. You are correct, guys. It's revenue. And Ethan, revenue is also going to be measured by what unit? Yep. So they're both going to be dollars, okay? Question says, what price will maximize the revenue? So, Jasmine, what are we looking for? What price will maximize the revenue? Is that input or output, guys? Price. Input, right? Good. Input is, so now Jasmine, what do you think? What are we looking for? What price will maximize the revenue? What are we looking for? In plain English. The what? The H value of the? Yes. The H value of the vertex. Do you guys agree with that statement? Yes or no? H is the input. So maximum, it's the highest point, which is your vertex. And Jasmine, what's the formula for the H value of your vertex? Yes, good job. Good job, hon. Okay, Sibby, what's A equals in our equation?
Negative 2.5,
Perfect. B equals?
500,
C equals?
0.
Yes. All right, Sibby, let's plug it in. negative b, which is negative 500, divided by 2 times negative 2.5. So Sibby, what's 2 times negative 2.5?
3. Or no, 5.
Positive or negative?
Negative.
Okay. And what's negative 500 divided by negative 5?
100.
Great. What is the unit of measurement?
Dollars.
Yes, good job. So the price would have to be $100 for this company to maximize its revenue. Okay. Emma, can you help us read number 4, please? Thank you so much. Okay. Juliana, what is H? What does it mean in this problem?
The height.
In what unit of measurement?
Meters.
Perfect. No longer feet. So that's why it's important for us to know. And then, Hannah, what does T represent in this? And then what does it measure in? Perfect. Way to go. Holden, help us read part A, please.
How tall is the catapult? How do you know what comes from?
Okay, how tall was the catapult? How do you know? And how do you know what you're looking for? What do you think? Brad?
The height would be the y-intercept.
Yeah, how tall was the catapult, right? Meaning that at time equals to 0, if t is 0, if the input is 0, then we're looking for the... You're right. Would you guys agree with that? Okay, so looking for the y value when t equals to what? 0. Okay, so if t equals to 0, we plug it in. H of 0 equals, what happened when negative 6 times 0 squared? It's 0. What happened to 42 times 0? 0. So what's the only thing that's left? 6. And what is the unit of measurement here, students? Be very careful. Meters. Yep. Okay. So it's the y-intercept. Part B. Zoe, help us read part B, please.
When did the company reach its highest point? How do you know?
Yeah, Zoe, what are we looking for? If we're asking you, when did the pumpkin reach its highest point?
The K value.
Is it the K value?
The H.
Yeah, because it says when means time. So looking for H value of the what, Zoe? Of the vertex. And what's the formula? Perfect. Good job. All right. For our problem 4, Devin, what is A equals? Good. B equals? C equals? Beautiful. We're going to plug it in. So negative B divided by 2 times A. That means we have a negative 42 divided by 2 times negative 6. So Cam, what's 2 times negative 6?
Negative 12.
Great. What's negative 42 divided by negative 12?
Uh, 3.5.
Okay, beautiful. So is that what unit of measurement would this be, Cam?
Seconds.
Correct. So students, in 3.5 seconds, your catapult will reach its highest point. Okay. All right. Part C. Annalise, help us read part C, please.
How high did it get? How do you know?
Yeah. How do we know? What are we looking for if we are asking you how high did the catapult get? Feel free to talk to your team too, Annalise. Okay, looking for K value of what, Annalise? Yes. Okay, we are looking for the K value of the vertex. So Keely, do we find the k value of the vertex? Yeah, we do plug in the h value. All right, we have a decimal, so make sure we guys have h of 3.5 equals -6 times 3.5 square plus 42 times 3.5 plus 6. All right, with the calculator, please punch it in. Lonnie, what's 3.5 square? Times -6? -73.5. All right, thank you so much. What is, Chris, what is 42 times 3.5?
147.
147 plus 147. Drop down the 6. All right, guys, everyone punch it all in your calculator. Spit out a number. Compare your team. Box it up with the correct unit of measurement, okay? When you have an answer, can you compare on your team first before you write in your notes? Sibby, do you have a calculator, hon? Go grab one. All right, Jake G, what did you get?
79.5
Unit of measurement?
meters.
Perfect. Okay. So the catapult goes highest at 79.5 meters. All right, part D. Tanner, help us read part D, please.
When did the pumpkin spot on the ground?
Okay. Yeah, Tanner, if we were asking you when did the pumpkin spot on the ground, what do you think we're looking for? You guys agree with that? On the ground, mean height has to be 0. You are correct. We are looking for the x-intercept. Because the y is 0. Because h of t equals to 0. All right, so set y equals to 0. Let me pinch it in to see the equation. -6t squared plus 42t plus 6. Okay. Now we are going to use your basic algebra to solve. How do we solve for the x-intercept, students? Sophia, what do you think you want to try to solve for the x-intercept? By the way, how many different ways are there to solve a quadratic equation? Name it for me. 4 different ways. What's the first way? Factoring. Second. Completing the square. And last. Quadratic formula. Technically, you can graph it out too, right? But most of us are probably not going to go that route. Okay, so we will try to see if it's factorable. To see if it's factorable, we're going to try to see if we can take out the GCF. What is, Bradley, what is the greatest GCF we have here? 6. Because it's negative in the front, students, we will take out a -6, okay? If we take out a -6, be very careful. We now have a positive t squared. If we take out a -6 in, what's left from the 42t? Yes, I love it because you said it correctly, -7 and -1. Then we're going to take each factor and we will set it equal to 0. Is -6 ever equal to 0? No, right? So we can cross it out because we know that it's not applicable. Okay, so t squared -17 -1 equals to 0. How do we solve that piece? Is it factorable, even just looking at it? No way. So what's the next choice? Is it y to complete the square? No, because b is b even. No, so you got one more choice. Quadratic formula, yep. Okay. The quadratic formula said x equals -b. So we don't have x, we have t. T equals -b. B is what in this question right now? What is b in here? -7. But it's a negative of -7, so it's what? 7. So -b plus or minus square root of b squared minus 4 times. A is what in our equation right now? What's A? What's A? 4 times A times C. What's A? 1. What's C? -1 all over 2 times 1. Perfect. Okay. I need more room, so it's going to go over here. T equals 7 plus or minus. Here we go. What is the quantity, Val? -7 squared. $49. Perfect. Good job. Kyle, what is -4 times 1 times -1? +4. Beautiful. 49 plus 4. It will give us what, Tyler?
What'd you say?
49 plus 4, bud.
53.
53. Great. Now use your calculator and round to 2 decimal places. Jake S., what is square root of 53? Ask your partner, Jake, if you don't know how to do it. Square root of 53? There's a button on your calculator. Guys, find it for me. What button are we pressing to find the square root? Well, especially you borrow mine. What button are we pressing? Second, and then what? You're right. You're going to press second if you borrow my calculator. What else? X squared, yeah, y'all. And then punch in 53, yep. And then round to 2 decimals for me, Jake. Okay.
Oh, okay. Then it's 7.2.
Perfect. Okay, now let's go further. Now that we know how to find those. Okay, 2 equations, guys. The first one, it's a plus, so 7 plus 7.28 divided by 2, because there's a plus or minus. And then the second is going to be 7 minus 7.28 divided by 2. All right, so Jake, do me a favor, do the plus one. Lonnie, do the minus one and give me the answer. Okay, Jake S, yeah, do the plus. 7 plus 7.28 divided by 2. Lonnie, do the 7 minus 7.28 divided by 2. So give me the answer whenever you guys are ready.
It's -0.14.
-0.14.
Minus 7.14.
7.14. Okay, both of these are going to be units of measurement of what time frame? Is it seconds? Can I keep both, students? Can we keep both? That's the question. Why not? We have an answer. Why can't I keep both? Yeah, we can't. Remember, every time you find an answer, we need to make sure that it makes sense. We're looking for the time that this object is going to be on the ground. We can't have a negative time frame. So even though that's your x-intercept, but in an application, we have to look back to see if it is applicable. Okay. All right, Haley, help us repartee.
How high is the pumpkin after 1.5 seconds?
Ooh, how do we find this? How do we find this? Ethan, how do we find how high is a pumpkin after 1.5 seconds? Find the what value? Not the K, because the K represents vertex. How high means you're looking for what? Input or output, Ethan? You're right. Output is H, right? So how do we find the height when we know time is 1.5? Yeah, just chuck it in. All right, guys? Find the height when t equals to 1.5. All right? All right, plug it in. H of 1.5 equals, let me go back to my equation to see what that was again. Negative 6t squared. So it's negative 6, 1.5 square plus 42 times 1.5 plus 6. All right. Let me make it bigger so we can see. Using your calculator if you need to. Jasmine, what's 1.5 square? Two, okay, times the negative 6. Negative 13.5, good job. 42, Sibi, times 1.5. $63. We're going to drop down to 6. All right, guys, everyone punch all of those in. Give me an answer, a final answer with the correct unit of measurement, please. Double check your friends first before we write it in, okay? Okay, box it up. Don't forget to write the correct unit of measurement. If you have an answer, verify it. Hey, Juliana, what did you get, hon? 55.5 meters. You guys all agree? All right, perfect.